what all you have studied till now in chemistry? Can you tell me the topics, including physical?
Including physical.
Physical, like anything in chemistry.
Mole concept.
And you want to have a overview.
Mole concept.
Yes, mole concept you must have studied.
Periodic properties.
Periodic properties.
Then chemical bonding.
Okay, chemical bonding also you have studied.
Yes. Then
Anything
atomic
else?
structure. Atomic structure.
Atomic structure.
Then stoichiometry. That comes
That's
more
inside mole concept.
volumetric.
Haven't you studied gaseous state?
Gaseous state.
Gaseous state. Anything on equilibrium?
Ionic equilibrium.
Ionic is also.
Chemical equilibrium.
Let's say equilibrium for right now.
Redox.
Okay. So, if you have studied or have an idea about periodic properties and chemical bonding, then you know overall how periodic table looks like,
Yes.
what elements are there, what electrical configuration of those elements are, and how they make bonds. So, we'll start off with that to just revise what you have studied in 11th, and then we'll go further. So it's hydrogen here, helium. What comes next?
Lithium.
You also make. I want you to do some more things on the table as well. So hydrogen, helium, lithium. Lithium के बाद क्या आता है? Lithium. Yes. And then here comes boron.
Carbon, nitrogen, oxygen, fluorine, sodium.
So this line is most important because most of them are the first element of the family. Okay, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here we have helium. Hydrogen shows some different kind of properties, but that's okay. So you must have studied about atomic number. What is atomic number?
It implies the total number of protons and electrons.
Proton plus electrons. Number of protons plus electrons.
No, it is number of protons which is also equal to number of
Electrons. But if protons are more than that, electrons.
protons are
More than electrons, then what?
positive.
So then we always go with the electrons, whatever electrons are there in their normal state. Whatever number of electrons are there in the normal state. So electron are the most important, which makes atomic number. Okay. So if I check helium, hydrogen ka atomic number, it's 1, right? So then it have only one electron.
Yes.
It is in 1s1. What about helium? Lithium 3. Till okay, boron I'll write one more. 1s2, 2s2, 2p1. The boron is 5, right? What is the neon atomic number? 6, 7, 8, 9, 10. Can you write कार्बन से नियॉन का इलेक्ट्रॉनिक कॉन्फ़िगरेशन? हाँ, एक बार लिख के दिखाओ. So neon का क्या आएगा? 2s2 56. So other than neon and helium, we can see that they have unfilled electronic shells, right? So if the electronic shells are unfilled, they are unstable, because stability comes if you have filled electronic shells. So because of this unfilled electronic shells, what they do, they make bonds with each other with different kind of elements, and there are different type of bonds also. So on that note, if I check on boron, 1s2 2s2 2p1. Now to get to a stable state, what boron should do? What options boron have to get to a stable state? Stable state means what? To have filled electronic shells. So it can donate this one electron. So boron gives out its electron, so that will become boron plus, right? And it can have filled electron shells. Or it can maybe take 1, 2, 3, 4, 5 more electrons to fill out 2p. But that generally atoms do not do, because atoms of this smaller size cannot hold 5 more electrons, because its size is very small. That's why. So what it can do? It can donate 1 electrons. So there are very different kind of donation. On that, we can see that which kind of bonds can happen. First is ionic, covalent. There is one more kind of bond, metallic. So in ionic bond, what happens? What is the most basic thing about ionic bond? Therefore, let's say sodium and chlorine. I'm validating examples because I think you have a fair idea about it, right? That's why. So if I take sodium and chlorine, draw the electronic configuration of sodium and chlorine. So what we can say is 1s2, 2s2, 2p6, 3s1, right? In 3s1, sodium have 1 extra electron. If it loses out that electrons and become sodium plus, then it is a stable state. If it gives that 1 electron, what the electronic configuration resembles to which element? Neon, right? So you can either remember like that, all the atoms try to make the electronic configuration identical to the gaseous noble gases. Okay, this all gases are called noble gases because they have filled electrons in their shells. So now sodium gave up its 1 electron, and now that electron will flow into chlorine plus electron, and chlorine will become chlorine minus, and its electronic configuration will be same as. So that's the electronic configuration of which element? Argon, right? Okay. So they try to make the electronic configuration same as noble gases. So now what happened here? The electron is lost by sodium and now gained by chlorine. It's an irreversible exchange. Okay. It is not like sharing that after once it is given to chlorine, after some time it will again come back to sodium ka shell. That doesn't happen here in ionic bond. If I take example of Li2, can you draw how the electron exchange will happen in Li2? First of all, can you tell me which kind of atoms, which kind of ions will be? So this are called ions, right? Anion, this is cation, and anion. That you know that if A B are making bond, A plus and B minus.
Yes.
A plus is the cation and anion. So here, what is cation? Which one is the cation?
Lithium.
Lithium,
Yes.
right? And Li have which charge? Plus, and the anion is
Oxygen.
O2 minus. Okay. So just make the electronic configuration first of Li and O, and then show the exchange and how the exchange will happen.
So it's an ionic bond.
Yeah, this all bonds are ionic bond. We are talking about ionic bonds. So there will be a complete transfer of electron out there. Okay.
So like this.
So I'll show you what will happen. So Li we have already did, it's 2s1. I have only one electron. You just need to lose only one electron to gain the stable state, which is of helium. Okay. So Li can only donate one electron. But here in oxygen's case, what is happening? It's 1s2, 2s2, 2p4. It needs two electrons to get to neon ka state, stable state. So oxygen needs to have two electrons to go to O2 minus. Okay, so if it is two electron, here only have one electron, so we need two lithium ions. Balance it out, you will get Li plus O gives Li2 plus 2 times plus O2 minus. Okay, that's lithium oxide. So like here you can see, we need to do balance of reactions when there are different valencies of the element. Okay, here by only giving out one electron, it goes to the stable state. Here by accepting two electrons, it goes to stable state.
Excuse me, sir.
Yes.
So there will become 1 plus. Lithium 1 plus.
Sorry. This is lithium plus. So now if I take a very generic example that a metal is there, which by donating p electrons goes to its stable state. So what will happen? M if gives p electrons, then what charge will come on M? Number of electrons is p, let's say. P can vary from 0, 1 to anything. M p plus, that much charge will come to M. And if X is my anion, by gaining QE electrons, let's say Q is the number of electrons it is gaining, then what will be power coming to X? Q times minus Here also Q can be anything. Balance out this reaction, what will happen? How will balance out this reaction? By multiplying this equation with Q, this equation with P, right? Because you need to take the electrons out. PQ, PQ. So then it will be QM plus PX gives out QMP plus P XQ minus. Is it correct? That way this will go out, right? So this is a very generic thing, but what I want to go here is to get you some examples of famous ionic bond. So let's start with Mx. If M is my metal, let's say cation, and X is my anion. Want to break it down? What will happen? M plus X minus. Here what will happen? 2 plus 2x minus. Can you give me an example? What example of Mx? Let's start with Mx. What will be an example for Mx? MgO is a good Mx. Oh, sorry. I have done M plus and X minus.
Okay. NaCl.
NaCl is a good example. So NaCl means what? Any 1, 2, 3, 4, 5, 6, 7. Right? So any first group element as metal and any 7th group element as anion will make up M plus X minus. Do you understand this? ये समझ में आया कैसा क्यों हुआ? So this is 1 plus 7. If we are going to mx2, m2 plus 2x minus. Example? AlCl. Do AlCl make 2?
CaCl.
Al do make AlCl3. We'll see that why it will make AlCl3.
Sir, CaCl.
Yeah, CaCl you can do. See, if you have seen Li here, Li can give 1 electron and goes to stable state. Be needs to get 2 electrons also fits to go to a stable state, right? So NeBe with a 7 group, right? BeCl2 will do second plus 7, right? Here in mx3 what will happen? M3 plus 3x minus. That is, I can take B, BCl3, right? Any problem, you can make the electronic configuration. 1s2, 2s2, 2p3. So it should lose out 3 electrons. That is third group element plus any 7th group. What will happen in mx4? M4 plus 4x minus, right? So that example can be CL4 or CF4 or anything. 4th group plus 7th group. Okay. Now M2X. पहले लिख लेते क्या होगा 2m plus x2 minus, right? H2O is not an ionic compound. You can see ionic compounds are made most of the time with this 2 line का metals. इधर नीचे से start होके lithium and beryllium with most of the time this 3 non-metals. Okay. We'll see how and why this is happening, but अभी के लिए 2m plus x2 minus. So m plus चाहिए ना अपने को with 1 plus charge. With 1 plus charge से कौन stable state पे जाता है? कौन सा group of element, कौन सा group इन सब में से stable state में आता है? 1 plus charge से?
1 plus charge से. First group, right? Lithium, sodium. They give just by giving this one electron, they go to the stable state. So
क्या ले सकते हैं यहाँ पे, सोडियम ले सकते हैं। एंड दो इलेक्ट्रॉन एक्सेप्ट करके कौन स्टेबल स्टेट में आता है, विच ग्रुप, ऑक्सीजन फैमिली, राइट। सो वी कैन टेक Na2O, this is first group plus 6 group. Now if we have M2X3, what is this M2X3? 2 times the metal का cation plus 3 times anion,
So Al2O3.
Al2O3. But how the balancing happens? So now what is the charge on M? How much charge is there on M? You can, yes, plus 3 and X have 2 minus. Why? How you can verify? 2 into 3, 6. So it has total 6. It has lost total 6 electrons. The 6 plus charge is there on the whole cation group. Here they have gained 6 electrons. So total 6 minus charge is there. So by that you can verify that क्या होगा इसके ऊपर. So 2m3 plus 3x2 minus. Al2O3 is a very good example. Al is in which group? Third group.
Yes, sir.
Third group plus 6th group. In this way, if I M3x पहले ले लेते हैं, हाँ, तो M3x में क्या होगा, 3m plus x की x with which much, how much charge?
Minus.
Exactly, 3 minus. Example, m plus x3 minus. Which one is a good example of M3x?
Sir, BC.
See, m plus तो है, so first group होगा, no doubt about it. Okay, so we can take any one, Li ले लेते हैं, Li 3 times ले लेते हैं. अब x क्या हो सकता है? By gaining 3 electrons, who goes to a stable state? Nitrogen. Li 3 है, right? If I take M3x2, तो क्या होगा?
M3x2.
ये ब्रेक कैसे होगा ये?
x2 minus.
First of all, 3 m है, ये लिख लो इतना. And there are 2x, right? Now you just need to know the charge. So what usually is the trick, that ये इसके ऊपर चार्ज लेता है और ये इसके ऊपर चार्ज लेता है, to balance out out. जैसे मैंने अभी यहाँ पे दिखाया, अपन ने इसको q से मल्टीप्लाई किया, इसके इलेक्ट्रॉन जितना से दिया, और इसको अपन ने p से किया जितना इलेक्ट्रॉन इसने दिया. That's why they both get cut out and we get the whole reaction. यहाँ पे क्या बना, फाइनल प्रोडक्ट क्या बना, देखो ना, m q m times q है ना, और x टाइम p है, तो फाइनल प्रोडक्ट क्या बना, m q x p. m p प्लस है इस पे, और यहाँ पे q है, x के ऊपर q माइनस चार्ज है. That is the trick, that 2 जो होगा वो इसके ऊपर चार्ज होगा और 3 जो होगा वो इसके ऊपर होगा. Now that you know that x is a anion, so उसके ऊपर कितना हो जाएगा, 3 माइनस चार्ज होगा, और m के ऊपर कितना होगा, 2 प्लस. एग्जांपल क्या हो सकता है इसका,
2 plus से तो बेरिलियम B
2 प्लस, यस, बेरिलियम
3 minus से N
3 माइनस, so it is
B3
and N2. Okay. Now if we see covalent bond, उसमें क्या होता है, एक A है प्लस B है, let's say, and they have made A bonded B. Okay, A have one unpaired electron. Do you understand what is unpaired electron, right? So A have one unpaired electron, B also have one unpaired electron. What they do, they share the electron. Okay, so let's say we can take example of H2O का ले लेते हैं एग्जांपल। ये O हो जाएगा, इधर H है, लेट्स से H का क्या होगा इलेक्ट्रॉनिक कॉन्फ़िगरेशन 1s1, O का क्या है लास्ट, आई एम जस्ट टॉकिंग अबाउट द आउटर मोस्ट शेल 2p4 राइट, सेकंड रो में ना 2p4। तो हाउ मेनी अनपेयर्ड इलेक्ट्रॉन H के पास है, ओनली वन, ऑक्सीजन है 2 unpaired electrons। So if इसके पास 2 unpaired electrons है, then it needs 2 more electron, right, to goes to stable state. So and this need only 1 electron. So we'll have 2 such H in the bond, right, with oxygen. We'll share the electron with oxygen and will make H2O. तो इसमें होगा क्या, O H H, ये भी अपना इलेक्ट्रॉन शेयर कर रहा है, ये भी अपना इलेक्ट्रॉन शेयर कर रहा है, ये भी कर रहा है, इधर ये भी कर रहा है। तो H का इलेक्ट्रॉनिक कॉन्फ़िगरेशन फिर क्या हो जाएगा 1s2, ये वाला H का भी क्या हो जाएगा 1s2, और इसने भी तो एक इलेक्ट्रॉन शेयर किया है इसको, मतलब दे हैव गिवन वन इलेक्ट्रॉन फॉर शेयरिंग। सो ऑलरेडी यहाँ पे ये था, H का भी इलेक्ट्रॉन शेयर हुआ, सो कंप्लीट हो गया इलेक्ट्रॉनिक कॉन्फ़िगरेशन। सो यू कैन सी हियर कि यहाँ पे इसके पास भी वो इलेक्ट्रॉन है और इसके पास भी वो इलेक्ट्रॉन है। That's what happens in sharing. You don't know at exact point of time that where the electron is lying because it's hovering around in this bond. Okay, that's how the bond works. कि sharing हो रहा है तो it's sometimes here, so making the configuration of both the element global. इसके A plus B gives us A and B. So if I want to take more example, तो क्या हो सकता है CH4, कार्बन 4 बॉन्ड बना रहा है हाइड्रोजन के साथ। कार्बन 4 बॉन्ड क्यों बना रहा है हाइड्रोजन के साथ? This means it needs 4 electrons to make the stable. So 1s2, 2s2, यहाँ पे क्या होगा कार्बन का कॉन्फ़िगरेशन
सर सब फुल हो जाएगा, भर जाएगा फुल।
पर पहले क्या था 2p,
दो ही भरेगा सिर्फ स्टार्टिंग में
2p2 राइट। सो इफ इट गिव्स 4 मोर इलेक्ट्रॉन, ये उसको मिल गया, सो फुल हो जाएगा राइट, कार्बन का नियॉन स्टेट में पहुंच जाएगा वो, एंड ऑल हाइड्रोजन अभी 1 थे, एक और मिलेगा तो हाइड्रोजन स्टेट में पहुंच जाएंगे। ओके, so covalent bond is I think more easy that you understand that. So this all are what we're talking about single bonds in covalent bond. There are multiple bonds between two atoms only, which are what we call them. If A and B are making a bond, it's A B. A B can make A double bond B, and A and B is making A triple bond B. So this is a sigma bond, this is pi bond, this is a triple bond, right? So what is happening in this multiple bonds? Let's say what is happening in double bond? इसने A 2 इलेक्ट्रॉन लेके आया होगा, B भी 2 इलेक्ट्रॉन लेके आया होगा to share, right? दो इलेक्ट्रॉन they are sharing in it. So if I take an example of AB का bond share, you can take CO2. पहले C का इलेक्ट्रॉनिक कॉन्फ़िगरेशन बताओ क्या होगा?
C का होगा 1s2, 2s2, 2p,
यहाँ पे O का क्या है
1s2, 2s2, 2p4,
2p4. So if there is only one C and 2 oxygen, C needs how many electrons? 4 more electrons to go to stable state. Oxygen can give oxygen just need only 2 electrons to go to the stable state. That's why we need 2 oxygens to go to stable state, right? But what happens here? 2 electrons, matlab, if 2 electron is given by one individual oxygen atom, so we need to show it by double bond. कि एक तो यहाँ से शेयर होगा और एक दूसरा और एक शेयर होगा, इसमें डबल बॉन्ड. So oxygen is making 2 bonds. One is sigma bond and one is a pi bond. And carbon is making how many bonds?
4.
Total 4 bonds. Where 2 are sigma, 2 are pi. Okay. If I want to say triple bond, how triple bond works, we can take example of N2. N का electronic configuration is
1s2, 2s2, 2p3.
2p3. Needs 3 more electron to fill it up and goes to stable state. Right? और इसको 3 electron चाहिए. The same nitrogen atom will come
Yes.
and can provide those 3 electrons.
Yes.
So N is making a triple bond with N. 3 electron sharing. Let's say